Right, so we have previously talked about how if you start with an expression for displacement, okay, and we just use as an example our constant acceleration formulae, we know that if you differentiate that with respect to time, you get u plus at, which we know is equal to v. And we've said again, if you start with an expression for v, if you differentiate that with respect to time, you get an expression for a. Okay, and that leads us to this little chart here, which says that to get from s, so displacement, to velocity, you differentiate with respect to time, and to get from velocity to acceleration, you differentiate with respect to time. So what we're going to look at now is, well, how do you go the other way? If to go from velocity to acceleration you differentiate, then to go the other way, so to go from an expression for acceleration to velocity, then we must integrate. So we integrate a with respect to t to give us velocity, and we integrate v with respect to t to give us displacement. Okay, so that's straightforward enough. If we look at an example here, so if you had a differential and you're asked to work out the equation of the line, so step one, we are going to integrate, so we add 1 to the power, so it goes x, we've got 3x cubed, and we divide by that new power, and 12x squared divided by that. And what's the one other thing we need to account for when we integrate? We must also have our constant of integration. So we get x cubed plus 6x squared plus c. And then the question becomes, how do you work out that c? Well, we need to have a known point, a known coordinate, or in the case of what we're going to look at, you need to have a known velocity or displacement and know the time at that point. Okay, because then you can sub in your t, sub in your v, and you'll be able to solve for c. So let's look at an example. Okay, so here we've got an expression for velocity. So we know that velocity is 6t minus t squared meters per second. Okay, these brackets, they look a little bit kind of daunting, but it just means the whole it's just like a way of grouping it all together to put the unit on it. So it's just saying they're all meters per second. And we want to find an expression for the displacement. Okay, so we want to go from velocity to displacement. Displacement is the integral with respect to t. So we're going to integrate 6t. So 6t, we add 1 to the power, divide by that new power, minus t squared, so it becomes t cubed over 3. And then we have plus c. Let's simplify. So we get 3t squared minus t cubed over 3 plus c. Okay, so at the moment we have an expression for s in terms of t, but it's not fully, this is the general solution, okay, because we've still got that plus c on the end. So we need some sort of known value. And what do we know? We're told that when t is 0, the displacement is at x equals 5. Okay, and we know the displacement represents motion along the x-axis, so the x value is the same as the s value. So when t equals 0, s equals 5. So then let's substitute that in. So 5 equals 3 times 0 minus 0 cubed over 3 plus c. So we find out that c is 5. Therefore, our full expression for displacement, 3t squared minus t cubed over 3 plus 5. And we want to find the distance of the particle from the starting point. Okay, this is key. From the starting point. So first of all, we need to know, well, where is it? Where does it start? We kind of told it in the question, but let's just revisit that. So find the starting point. So when it starts, t is 0. And we've got our expression for s. So when t equals 0, s equals 5. Okay, so starting point is s equals 5. And then we want to know, well, where is it when t is 6? So let's find out. When t is 6, s equals 3 times 6 squared minus 6 cubed over 3 plus 5. 108 minus 72 plus 5. 41 meters. Okay, so the distance from the starting point, from start, is 41 minus the starting, which is 5, 36 meters from start. Okay, and here's a question where we're given an expression for the velocity. So velocity is 5 minus 3t squared. And we want to find the distance travelled by the particle in the 3rd second of its motion. Okay, so we want an expression for displacement. And we know to get displacement, we're going to integrate v with respect to t. So we're going to integrate 5 minus 3t squared. And that is going to give us 5t minus 3t cubed over 3 plus c. That's our displacement. So 5t minus t cubed plus c. Okay, and at this point here, we want to work out the distance travelled in its 3rd second of motion. So that is the distance travelled between when time is 2 and when time is 3. Okay, because first second would be 0 to 1, second 1 to 2, third is 2 to 3. You'll note we actually don't have enough information in the question to work out what c is. Okay, but in actual fact we don't need to. C effectively represents the kind of the offset, the starting point where it starts, i.e. in the previous one we looked at it was 5 meters. Okay, but in this case we don't need it, because if it starts 5 meters, when we sub in 2 it will have that plus 5, and then when we sub in 3 it'll also have that plus 5. So effectively we just want to say, well, when t is 2, s is 10 minus 8 plus c, so s is 2 plus some constant, and when t is 3, s is 15 minus, that'll be 27 plus c, so minus 12 plus c. So the difference between the two is, so S3 minus S2, the C's are going to cancel out, and so we get an answer of minus 14, because it's minus 12 subtract another 2. As a distance, we don't have a negative distance, we might have a negative displacement, but distance is always positive. That's 14 meters. How we could have also done this is to integrate our expression for velocity between the two t limits that we're interested in. Okay, this is a more robust method, so it's effectively finding the area under the curve, because the area under a velocity time curve, if you've got a velocity time the area under there is the displacement. So that's effectively what we're doing, but in this case we're saying between 2 and 3, what is the area? So we integrate between 2 and 3, which is 5 minus 3t squared, between 3, sorry, that's supposed to be a 2, between 3 and 2, which is 5t minus t cubed, 3 and 2, so we sub it in, 5 times 3 minus 3 cubed minus 5 times 2 minus 2 cubed, and we get minus 12 minus 2, which is minus 14, and the same logic, the distance is 14 meters.